Okay, so these are the chapters that we have left to cover. 14, 18, 19.2, 19.4, 21 to 25.5, I mean 20.5, 21, 22, 23, I mean 24, 25.1, 25.5, 25.10, and then 26 through 28. That's going to be kind of a little bit of a mixture. It's not going to be the whole complete chapters, because there's a little bit of anatomy dispersed in. Okay, so we're going to start with 14. How's your weekend?
A little slow,
A little slow?
a lot of lack of sleep.
Yeah, you're preaching to the choir there. I usually get caught up on sleep, but I'm trying to please too many people, and so just there's not enough hours to get everything done.
Yep. And then I got some weird chest pain right now. I think I breathed wrong.
You got weird chest pains.
Yeah. Literally happened right now. Ow.
Okay.
Other than that, nothing of much.
Okay, so well, don't get sick in the middle of a lecture. If you need to stop, let me know. And it's recorded already, so we could just go over the recording. So,
I don't think it's more of a sickness. It's more like I cracked something.
Okay.
I'm fine.
Okay. Well, you just let me know. It wouldn't be good to lose a student in the middle of class. Okay.
That's not funny.
So let me tell you a little bit about my weekend. So this weekend, well, a little history, right? So I work all the time. So usually during the week, I'm eating either junk food, like eating out all the time, or I'm eating like ramen noodle, something that I can fix really, really quick. And so on the weekend,
Yep.
I typically get a little more time since, I don't have classes all day. So I like to cook at least one meal on the weekend. And breakfast is one of my favorite meals because you get a little bit of sweet and savory, and it's okay to have them at the same time, So, and it's usually fairly easy to cook. So this weekend, I decided I was going to cook, we're going to have a nice little layout. And my girlfriend had the late shift. She was working a late shift. She didn't get off till 6 in the morning. So I figured we'd do a brunch, And so, I cooked. In my family, there's a traditional food. It's called mackerel, fried mackerel. And so basically, in the South, if you're like kind of close to water, things like that, you'd actually go fishing, and it didn't matter the type of fish you got, and you just basically make like a fish cake, right? And so it just basically be all of the leftovers of the fish, pounded together, and then you put like crackers and seasoning in it, and you fry it. And so, and it's delicious with syrup. Usually you have it with syrup and biscuits. So I was making mackerels, and I made hash browns and pancakes because I didn't have any biscuits, so I was using pancakes instead of that. And so, I was going all out, I'm going. And as I'm cooking, all of a sudden here, poof. And I'm like, what the hell was that? And I kind of look around, and it didn't really pay that much attention. And then, a few minutes later, I'm starting cooking and really making progress. I hear poof again. And then next thing I know, I'm sitting there going again, and I'm like, okay, what in the world was that, And I kind of look at the stove, and the stove is smoking a little bit, but not too much. I'm like, but you're cooking, so it's gonna smoke a little bit. So next thing I know, whoosh, right? So big old flame, right? on the stove. And I'm like, what the hell? And my first response was, to see if the heating coils were warm. Now, of course, I had just been cooking. So I put my hand on the heating coil, and you could just imagine what happened at that point, right? And not only that, I realized that it actually had fried through the wires. So my stove is an electric stove. It fried through the wires of the heating coil. I don't know what happened, and it caused the whole entire stove to short. So the stove wasn't working at all. And so burned my finger, and so my peeling skin, I basically peeled off the burnt part for the most part. I was fortunate enough that when I put my hand down, I guess I didn't put my whole hand down. I only put my index finger, and it got burned pretty nicely. So, yeah. So the moral of the story is, it's like, when things are sparked, sometimes you got to think a little bit and respond to those temperature receptors that are in your hand, and then that kind of brings us to our current topic. So when I put my hand on the stove, right, obviously I wasn't using my full brain, because otherwise I would have put my hand on the stove. I sit there, I have to rely on the reflex or the response to the sensory that I was getting from being stimulated, or a stimulus. So today we're going to be talking about the autonomous nervous system. And we're going to talk a little bit more about the receptors that are in that system, their function, and certain aspects of the system itself. Primarily, we're going to be focusing on that sensory components.
Did you ever finish the macro?
Yes, we did last week.
Really? I thought the stove short-circuited.
It did. Oh, you're talking about the food. Yes, I did. I actually took it to my sister's house to finish it.
Okay.
My sister lives around the corner from me, so. And it was funny because I could just imagine what, we're in the middle of COVID and everything like that. I'm walking out with a frying pan of mackerels, and then I was trying to bake some cookies as well. So it was an all-out brunch, but I shorted the stove, so my cookies weren't done. So I had my cookies and my frying pan in one hand, and a sheet in the other. Yeah, it was a little embarrassing. I didn't give it too much of a thought. Obviously, that's what happens when you don't get enough sleep. You don't think things through clearly.
Food. I need food. That's all you're thinking.
Exactly. Yeah. And and it's funny because I look forward to the Sunday, the Sunday breakfast or brunch, and I look so forward to it. Sit down, relax. I can relax for about an hour or so and not worry about, oh, I gotta go get this done and I gotta go get this done. I just, I'm gonna breathe a little bit, So, okay, so let's get started. Okay, so a lot of the receptors that we're going to be talking about are kind of going to be classified by cell type. So these are kind of three different cell types. One of them is the free nerve ending neurons. So these are neurons that have the dendrites that are basically free. They're not encapsulated. Now these dendrites. So they're often going to be embedded in tissues, and they're going to be kind of involved in just your sensations. So you're also going to have, and so in this case, they're going to be kind of embedded in connective tissues. And the encapsulation is there to kind of enhance their sensitivity. And then we have cells. So these guys are going to be kind of like your, in this case, this is an example of your rod cell is photoreceptor. And so these guys are going to have specialized functions. So all of these cells basically are going to be responsible for, when we're talking about receptors, these are receptor cells. So the cell as a whole is acting as the receptor. So these cells are going to be able to sit there and release those neurotransmitters onto a bipolar cell. So now, receptors are also key annotate. So receptors are also going to be categorized by their location as to the proximity to the stimulus, right? And so we have so these guys, the exteroceptors. So those guys are going to be receptors that are going to be located near the stimulus, and particularly the ones that are near the outer environment or external environment. Okay, so we also have the interceptor. So that those are going to be kind of like the ones that are located near stimulus that occur in your internal organs. And we have the proprioceptor. And these are going to be your movement. So we also have receptors based upon their function. So we have the chemoreceptor. So these receptors are basically used to interpret chemical signals. Or chemical stimuli. We have Osmo Receptors. Do you remember osmosis from chapter 3? No, 2.
Like osmosis and facilitated diffusion?
Yes. Yes. So in the context of osmosis, So when you have, let's say, a cell, if the concentration outside of the cell is greater than the concentration on the inside of the cell, that concentration outside is considered to be hypertonic. Okay. Now, as a result of that, the fluid inside of the cell is going to flow out to try to get the concentration of the stuff outside and the stuff inside to a form of equilibrium. Okay. And so an Osmo receptor, it actually recognizes the difference in concentrations between those two, the inside of the cell and the outside of the cell.
That's what triggers it then?
What was that?
Is that what triggers the
Yes,
to do it?
that
Okay.
receptor. So a nociceptor So a nociceptor basically recognizes, let's say, tissue damage and basically chemicals that are associated with like tissue damage or with some type of intense regulation. So
So this one's responsible for pain.
yes.
All right. Nociceptor.
We have our Mechano receptors. Okay, these are gonna sense the presence of vibrations and pressure. So these are going to be, oops. These are going to be important for like let's say our ear functions and stuff, things like that. And then of course we have our Osmo Receptor, which temper. Okay. Okay, so first thing we're going to be looking at is taste. Okay, so I apologize for these images. I know that they're not the best. Okay, so we have the circulum Papillae, spell that too. papillae. And so this, okay, so on your tongue, there's all of these little small bumps, right? And these bumps, they're going to be responsible for helping us sense the chemicals that we're tasting. And our tongue is going to be kind of divvied up in different regions of different types of papillae. And depending on the regions and the papillae, that's going to be responsible for a certain type of taste. Like we have sour, we have sweet, we have salty, we have bitter, you know. And so your tongue is kind of organized in a fashion that is able to sit there and recognize those different chemical responses, those different stimuli. Okay. So there's 4 different types of papillae. So we have the circumvallated. And so if you kind of take a look, this biopsy here, you can see at the top, it's more cylindrical. It has the shape that's going on here. These guys here, this guy is called fungiform. Okay, now these guys, they're getting their name sort of because the shape that they have is sort of a fungal shape, kind of big old clustered head, and you have the little sensory organs at the top of the tongue, well rounded, pretty thick, and evenly distributed there. These guys are called filiform. These guys have like little spikes. This guy is follated form. Okay, so these are just like these little biopsies of where those bumps are located. Now within those bumps, if we take a look at them, so at the top we have these at the top called like taste hairs, and then we have taste pores. Okay, so the taste hairs actually kind of collects the food itself, or collects the stimulus, and then it goes through the taste pores, and then that sends signals down the way. And so as it's internalized, the signals are going to be recognized. So like, for instance, if we're talking about salt, it'll recognize it as being salty based upon the ion concentration. So based upon the chemical characteristics, it's going to be able to sit there and determine it's going to be chemical characteristics to kind of determine what type of taste it is. You know, so for instance, the sodium ion is going to be associated with that salty, so it's going to recognize and collect those signals about the sodium ion, and then that's going to cause a depolarization of the cell membrane, and then that's going to generate a receptor potential. So it's going to depolarize the cell membrane and generate a receptor potential. Now, sour taste is associated with acidity. So like, have you tasted vinegar?
Yes.
Pretty sour, right?
Worse, yeah.
So the reason why it's sour is because it has an H plus concentration. So a hydrogen, that's associated with that sourness, that hydronium ion. And then again, in that case, it's going to generate a molecular and then depolarize the that gradient. And the cells themselves are called the gastrulary cells. And so these are gastrulary receptor cells, because at the top you have the little hair structures, then it goes down to the pores. And so they pick up those ions that are found in food to give us that. And so there are other, like the hairs there are going to be other hairs that are going to be able to sit there and determine whether something is sweet or savory, So we're able to sit there and pick up all of those different types of taste. Okay. So now what happens is that potential, because you got those electrons that are going to be going in, the electron potential is going to be going down the gastrulary receptor cells, and then those are going to be transmitted down to activate your other sensory neurons. So like, for instance, we taste something that's kind of bitter, right? So what is that face that you make when you're like, it's just like,
Yeah.
like a really, really sour pickle, you kind of get that look. So it'll cause all of those nerves to be activated as a result of those responses.
Mm.
Okay. And there's something else I wanted to say in this video. Sorry. Okay. Our next system is the olfactory system. So the olfactory system is basically smell, right? And if you take a look here, so this here represents the whole olfactory system. You have the olfactory bulb, the olfactory tract along here. You have the olfactory epithelium, and so if you take a look at your nose, right? So you take a big whiff, like say you take a big whiff of vinegar, or if you take a big whiff of poo, right? So you have receptors that are going to be located in the mucosa of that. And so if you actually take a look here, it's really hard to see, and I apologize. I need more time to get my images together. Still some from online. I mean, borrow some from online, giving them credit, of course. So we have the receptor here, and it actually is going from the mucosal surface all the way up to that the olfactory tract, and it's going to be going. It travels through the emodial bone, and then it forms a synapses at the olfactory bulb. So this guy continues, and it goes to the olfactory bulb where the synapse is held at. Oops. Sorry, there we go. Okay, the next part is, so this is the structure of the ear. We're not gonna, well, we need to know components, but we want to know more what is going to be functioning, what we're talking about. And so basically, we have the articular, the ear canal, we have the manuus, the incus, and so we have the status and the vestibules, the vestibule nerve and the cochlear nerve. We have the round window and the cochlear. We have the esthesian tube, we have the tympanic cavity, and we have the tympanic membrane. Now, what happens is as our ears pick up those vibrations that are given from sound, it'll actually enter that inner ear, that ear canal, the external part of the ear. Those sound waves are then they're going to be alternating. They're going to have high pressures and low pressures associated. And so depending on the frequency, they're going to be higher. Those sound waves are then they're gonna cause the tympanic membrane to vibrate as a response to the waves. So you're gonna get that membrane vibrating inside. So then that vibration is going to be amplified across the oscillus. So the oscillus then transfers that over to your manuus, and then it works its way down. It works its way down to the fluid that's found in the vestibule. So the vestibule then actually adds pressure bends, and so these pressure bends actually bend these hair cells that are located in your basal membrane, and that bending causes more vibrations. Right? And so, and those vibrations, based upon whether they're high or low, they're going to be recognized in that cochlear duct. And I'll show you a figure here of that in a second. Okay, so we have three major spaces within the cochleae. So we have the scalia vespuli, we have the scalia tympani, and so those both are located over on the outside of the cochlear duct. So within the cochlear duct, we have the tectorial membrane. So these guys are going to kind of be collecting, right? And then they're going to be transmitting the information to that cochlear duct area. So the cochlear duct is in between of the two. And so that is going to end up, so the other two are going to lie on both sides. So you're going to have that collection, and then it's going to go to the cochlear duct. At the cochlear duct, you're going to get the hair receptors to start bending. And then that's going to affect, or I should say, that the tectile membrane is going to start bending as a result of the two spaces areas getting those vibrations. And then that's going to cause those hair follicles to bend. The hair follicles bending is going to cause those pulses to travel down.
Okay.
So if you take a look, this is called the organ of Cordy. So the organ of Cordy basically holds those hair follicles. Okay, and so the hair follicles are actually tethered to the tecular membrane. Here's here. Come on. So they're tethered to the tecular membrane. So as that membrane moves, right, as a result of the space that are collecting those vibrations, then those follicles, those hair follicles or the hair cells are going to sit there and bend. And at that bend, it opens up those ion channels. And so then you're getting the depolarization of those, the membrane, the axon membrane. Okay, so so those hair cells are connected by stereocilia or cillae. And this is just a picture of the foliae and the organ of Cordy. So, as I was saying earlier, so going down the stretch of the foliae, we get all the way to the apex. It's able to sit there and determine whether you have high frequencies, low frequencies, or medium frequency, or low frequencies. So depending on the length of the length of the hair follicles, or I should say, or the distance where the hair follicles are located, it's going to recognize the different ones. So that first stretch is going to be recognizing the high frequencies, so that's 20K hertz, you know. The middle frequency is going to be around 1500 hertz, and then low frequency at the 20 hertz range. So, and so those hair follicles all in that area are going to be responsible with again, the low frequencies closer to the apex, the higher frequencies closer to the round window. Okay, so the macula is basically responsible for recognizing linear acceleration. So do me a favor, nod up and down. When you nod up and down, but do it slow, but do a really strong nod, you know. Do you feel that pressure and that sensation in your ear as you nod?
Yep.
Okay, so what that is, it is the otolith. So the otolith is basically calcium carbonate. It's like a little layer of calcium carbonate that the hair follicles or the hair cells have been embedded into that calcium otolith. And so when we move our head like and up and down, so that gravitational force pushes the otolith level down. The otolith level, it pushes it down, and so that force causes those hairs to bend, and those hairs to bend sends that signal to our nerves, right? And so, and then that lets us know, in that sense, that concept of balance.
Right? I wonder if you can trick them.
What was that?
And well, I wonder if we can trick them, because you know when we go to like amusement park rides and they try and they do like the Transformers ride in Six Flags, it feels like you're falling down, but you're actually just in level headed and all that.
Yeah.
Does that affect it?
So you're saying the perception, of you falling down compared to you actually falling down.
Yeah.
Right, so that movement. So in other words, you're playing with your brain. So in that sense, you're not getting the true response. And so your eyes are telling your brain, because your ear isn't telling your brain, right?
Mhm.
So your eyes are telling your brain one thing, oh crap, we're falling, and your ears. And so you're, in a sense, I guess you are kind of overriding the impulse, right, that you would get. So that context, you're getting another signal from your visual. Your visual says, I'm falling, where your that linear acceleration isn't saying that, you know.
Mhm.
So yeah, I guess so. If we kind of look at it like an electrical system, right? So we have a couple of points of control, right? So with an electrical system, we have the point of let's see, if we if we think about like a circuit, we have the circuit board and we have the power outside. So at any point, if something goes wrong with that circuit board, we can always cut the power out on the outside to control it as well. And so I think the brain kind of functions the same way, because it's just, in a sense, the same concept of electrical pulses, right? So you have overrides, and so your eyes can act as an override. Hey, this is happening, even though your eyes are lying to you in this context, and your body's telling you the truth. But I think it's like it's a backup system. So
You could always just close your eyes and feel the truth instead of seeing it.
that's right.
Okay.
Yep. So let's see. Okay, so if you turn your head left and right, we have a similar system. So again, you're going to have that rotational coding that's happening there. And so here you have your semicircular canals that are going to be functioning. So you have your cupula and your ampulla, right? So your cupula is being shifted in the ampulla, or in that canal. And so as you move left and right, it's causing those hair follicles to sit there and be pushed, right? And so you're getting bending of those hair follicles, or those hair cells down here, okay? And so those send signals to your nerve. And so your ampullary nerves are picking up those signals that are being sent by those hair follicles. Make sense so far? Okay, so these are, this is mostly structures of the eye. So we're just going to talk about it real briefly. So the biggest thing to know is that, so we have the eye, and it's located in the orbital. And then around the orbital, we also have a lot of soft tissues that's going to protect and support its function. And it's also surrounded by cranial bones. So the organization of the eye, you're going to have those nerves that are going to be sitting there feeding into it, and also feeding into the bone structure as well too. So this is just some of the extra ordinary muscles. We're not going to worry so much about that, but we're going to talk more so about those, right? So if you, although again, this is not the best image that we have here, but so the very top figure is basically showing you a little dissection of the eye itself, and So if you take a look at it, so the light is going to be going in. You have you have what we call your rods and your cones. And so on your rods, you have a regions where you have your disc. And so your disc are they're going to contain the rhodopsin pigment. And that rhodopsin pigment is going to be kind of important for you to do that sensing. So opsin comes together with retinol, a retinol isomer, and that actually forms the rhodopsin compound.
Mhm.
And then that's what is in that disc. So the rhodopsin compound is responsible for collecting that light. So it actually kind of collects that light and causes a conformational change between the retin, and then that results in that modification. But that sends those signals along here. And it's important that you kind of understand. So when we talked about that vesicular processing, so vesicular trafficking, do you remember we talked about that in chapter 4? You know, vesicles going from the ER to the Golgi, and from the Golgi to the lysosome, and the Golgi to the plasma membrane.
Mhm.
So if we thought about it, you know, you had all of these structures that existed in the cell, and you have this big thing of the Golgi, and there's a directional flow, right? So this is even more directional in regards to that directional flow, because if you think about it, you probably have these structures throughout the entire cell. Depending on the type of cell, it could be going in all different directions. Well, this one has to be organized a certain way. And so they organize the location of the organelles and the nucleus in the inner part of the segment. And then on the outer part of the segment, you have your disc that are forming. So you have your rhodopsin, or your rhodopsin disc that contains, I should say, the disc that contains all your rhodopsin pigments. Let's see. And so this is a diagram, and this is actually a dissection. And so you can actually see a cross section of the retinal tissue.
Mhm. If it weren't organized, the person would probably be blind or colorblind.
That's right. It would also, if it didn't have that organization, it would take forever for things to be delivered, you know, in the way that it should. You know,
Oh, so
so
there's like different types of screw ups per se.
yes.
Because I know my dad needs glasses, and it's because of the cones then?
Yeah.
Oh, okay. So there's people that need glasses, people that are colorblind, and then those that can't even.
See it all. Yep.
Yeah.
Yeah. Okay. So this is just basically showing you that cycle. So retinol is it forms an isomer. So an isomer is a chemical that has the same two chemicals that have the same chemical formulas, but they have different chemical structures. So a lot of times I use the different types of sugars as a result of that, like glucose compared to fructose. Fructose has a 5-carbon ring structure, and then fructose has a 6-carbon ring structure. Okay, and so, but they have the same chemical formula, C6H12O6, but the structures are different. So that's the same thing that's happening here in the case of these rods. and the retinal disc, right? So you have, and I apologize again that you can't see this, but I'll type it out. And in your book, it's a typo. So A is, so this structure here is, it's 11 cis. Actually, it should be 1, 1, 1, 1, cis. Right, 11 cis retinal. And then this guy is a 11 trans retinal. Okay. So what happens is, at the very beginning, the opsin, and this has opsin in it,
Mm-hmm.
it comes in contact with the 11 cis retinal. The 11 cis retinal together with the opsin forms rhodopsin. And then rhodopsin picks up that photon. So the photon of light is being picked up. So it picks up that photon of light. That photon of light causes a chemical change. So you see that little hook there? It actually becomes straight, so then it becomes trans. So you have the hook here, it straightens out, it becomes trans. So in that case, you have 11 trans retinal, and then it gets unbleached. It goes through an enzymatic reaction and gets converted with an isomerase, a photoisomerase. He uses up that energy, and then he goes to that process again.
Okay.
And so let's see. Yeah, that's pretty much it. Okay. And this is where I stopped with the other class, because we're just getting ready to start this and we ran out of time.
Oh, okay.
You know, it's funny. It's so much easier. I always finish 30 minutes. It's also because it's early morning, and I'm still trying to get my thoughts together before I get started. By this time, I'm still I feel like I'm still getting my thoughts together, but I'm not quite all there yet. But I'm better than I am when
Especially after doing the first class and knowing what you're already going to say.
yeah. And usually kind of gives me an idea of what I need to focus on a little bit more, than others, because based upon the questions that they have, and they're really good about asking questions in that class too. So, but we'll pick up here on Wednesday, and we'll finish this, and hopefully we'll finish 15.
Okay. You're gonna. I don't think I'll be able to do Thursday for the test.
Okay.
Is it okay if we do in your office hours, but on what? Wait, let me restate that. Is it okay to do it on Friday, where your office hours were normally at? So around 2:30.
Yeah, we should be able to do that.
If not, just let me know.
Yeah, we should be able to do that.
Okay. Thank you.
Okay, no problem. Okay. There's something I wanted to say. Jesse, what did I say in the class? Oh, so the exam is already posted.
So posted fish lab, physio X
Yeah,
lab.
the fish lab is, oh, the next fish lab is gonna be on Wednesday. I'm still pulling it together, so I have it done tonight. So it'll be
Mhm.
like tonight. You already have your next lab up, and it is a physio exo. At first, it wasn't gonna be a physio exo, but it ended up being a physio exo.
Yeah, that's fine. Should be easy enough to do. Okay, well, thank you for the class.
No problem. So then I'll see you on Wednesday then. And good luck studying.
Thank you. Have a good day.
You too. Bye-bye.